Hello, and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of graphing functions and identifying features. This is standard A.3C in the great state of Texas, and we are using item number 22 of the 2024 released STAAR test. This is a new item type called graphing, and if you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and then we will look at our answers together. All right, so we simply need to graph this equation. All we have to do is select 2 points on the graph, and it will graph it for us. And it's just a 1-point problem, even though this is a new item type and we have to have at least 2 points. There's only one line that's going to work. Doesn't matter which points along that line you choose. So we've got two ways that we can initially solve this, and there might be others. But let's look at just trying to identify the x and the y-intercept. Because if I can find the x-intercept and the y-intercept, well, then I can get my 2 points, right? And that's the whole point of having a linear equation is as long as you've got the 2 points, it will show you that line, and all the rest of the points along that line will also work. So the x-intercept is when it crosses the x-axis, right? And my x-axis is right here, and you notice we don't know what the x-coordinate is, but I can tell you that the y-coordinate is going to be equal 0. So it's going to be an ordered pair, and my second coordinate is going to be 0. And if I'm looking at my y-intercept, it's when it crosses this y-axis right here that I've got in blue. I don't know what the y-coordinate is, but I can tell you right now the x-coordinate is 0. So then it's going to be like this. All right, well, I can use that information, and I can just plug those numbers into, take a look. 2x plus 3y equals 6. Well, if I want to find my x-intercept, what I want to do is I want to make my y-coordinate equal 0. So let's make y equals 0. So 2x plus 3 times 0 equals 6. That just makes 0, so it's 2x equals 6. So then I can do x equals 3 when you divide both by 2. All right, so it looks like I could say my x-intercept is going to be at 3, 0, so I could put a point right there. And then, let's see, my y-intercept, same thing, but let's just go ahead and make my x equals 0. So 2x minus or plus 3y equals 6. I want my x to equal 0, because that's what I have here for my y-intercept. So that's going to be 2 times 0 plus 3y equals 6. That just becomes 0. It's 3y equals 6. Divide both sides by 3. And look what I get. Y equals 2. So it looks like my second point could be 0, 2. So it looks like I've got a line that kind of comes down here, if I drew that straight, and I just need those 2 points. Now, I said there's a few different ways to solve this. Some of you might have immediately saw the standard form and said, well, if I can get that into my slope-intercept form, you can graph it. And if you thought that, you're correct. So let's do that over here. 2x plus 3y equals 6. So we want to isolate this y. So let's subtract 2x from both sides. So that's going to be 3y equals, and I'll go ahead and put the 2 in front, negative 2x plus 6. And then you divide both sides by 3. And you get y equals, I get to distribute this out, negative 2/3 x plus 6 over 3. And so what you get is y equals negative 2/3 x plus 2. Now, the y-intercept is still going to be 2. So that didn't change. You notice how we got our y-intercept of 2? So let's see our y-intercept of 2. Let's see if it really has a slope of down 2 over 3. 1, 2, 3. So they both get you that same thing. Let's just go ahead and get that 2 and that 3, and let's see, did we match? We got pretty close. All right, so you could also, if you wanted to, you can substitute one of these points right here. Like you can take this negative 3, 4. You can plug that back in to make sure that the equation still balances if you want to double check your work. But that is our answer.